Hello, my name is Cerf. I'm Vice President and Chief Internet Evangelist at Google. And I appreciate an opportunity to address the VNNIC conference. I've not been in Ho Chi Minh City, but I have been in Hanoi, and I look forward to a return visit someday. Meanwhile, you'll have to put up with virtual Vint. The topic is the Internet. This is the 50th anniversary of its original design in 1973. It went into operation on January 1st, 1983, and it's been running and growing ever since. So we might want to look back and ask ourselves, where are we now, and where do we need to go from where we are? We certainly are touching about 2/3 of the world's population with some access to the internet, direct access to the internet. And it hasn't hurt to have low Earth orbiting satellites like Starlink and OneWeb and others to provide access literally to every square inch of the surface of the Earth. There are still open questions, for example, whether it's affordable for everyone, whether the data rates are adequate. All of those questions still to be determined. But certainly in terms of access, that's been a big step forward. The other things that have been happening over the course of the last roughly 40 years have been a significant increase in optical fiber, undersea cable especially, linking the continents together. In addition to which, mobile telephony has been helping with internet access, especially with the advent of the iPhone and subsequent other smartphones around 2007. With Wi-Fi and with 3G, 4G, 5G, and now 6G coming, all of these providing increased bandwidths and convenient access to the internet. So we can see that both radio and optical fiber and, of course, satellite communications are rapidly increasing opportunities for access to the network. So where else are we? Well, we can certainly say that the application space has dramatically expanded, particularly after the arrival of the World Wide Web. Around 1991, Tim Berners-Lee announced the World Wide Web, and I would say it wasn't widely visible at that point. But a couple of years later, Mark Andreessen and Eric Bina introduced the Mosaic browser, which got everyone's attention. It caused a company to be started called Netscape Communications in 1994, which went public in 1995, and it led to what is now called the dot boom, which lasted for about 5 years until roughly April of 2000, if memory serves. That led to the big dot bust, when a lot of companies that got started in anticipation of the importance of the internet ran out of capital, and many of them died at that point. But some companies that were started during that period have survived. For example, Amazon is one, Google is another, and there are others as well. Companies that got started a decade before that, like Cisco Systems, have thrived in providing equipment and software to allow people to build more pieces of internet and interconnect them. Another thing that we can observe, of course, is that safety and security have become an increasingly important part of the network concerns, as well as privacy. How are we doing there? Well, I would say it's a mixed bag. First of all, we've added a great deal of cryptography to end-to-end communications. So many of you using the World Wide Web are using it with the HTTPS protocol, the secure version of HTTP. Google introduced another idea called QUIC, Q-U-I-C, which combines the TCP and the TLS layers for more efficiency and adds a few other interesting functional features. We're also very concerned, of course, about user authenticity. And here, usernames and passwords are clearly inadequate, and we've been introducing other kinds of strong authentication measures. At Google, we use small hardware devices that plug into the USB ports of laptops and desktops and pads and mobiles as a way of hardening and making it harder for someone else to pretend to be you. We need to help the general public and others who use the internet to recognize the importance of strong authentication measures, including these sort of two-factor authentication ideas. So we still have work to do to spread that meme throughout the network. Similarly, we need to reinforce the safety and security of the underlying systems. For example, the networks that are interconnected use something called the Border Gateway Protocol to establish routing information to allow traffic to go from one end of the network to another. And that protocol can be spoofed either by accident or on purpose. The consequence of that is that we need mechanisms that will allow us to secure the routing information and make it hard for someone to either accidentally or deliberately introduce bad routing data. Same argument could be made for the domain name system. We've introduced the concept of DNSSEC, DNS security, which involves cryptographically signing the binding of a domain name and an IP address and making it harder for someone else to change that binding and direct people to the wrong target. All of those techniques have been only partially implemented in the net, so there's still work to be done to get everyone on board. There's a similar challenge. The original internet design used something called IP version 4 with a 32-bit address space, which turned out not to be enough address space for the rapidly expanding internet. In '96 or so, another format for IP addresses was introduced called IP version 6, 128 bits of address space, roughly 3.4 times 10 to the 38th addresses, which is enough to last until after I'm dead. Then it's somebody else's problem. But even there, we've only seen roughly 35 or 40% perhaps of the network running both v4 and v6. And we need 100% of the network to have both capabilities so that we can take advantage of the larger address space. And finally, just to add a little cherry to the top of the cake, there has been a project underway since about 1998 to look at the expansion of the internet literally across the solar system to support manned and robotic space exploration with more than just point-to-point radio links. And so that design has led to a new suite of protocols that are called the Bundle Protocol Suite, which take into account the fact that the distances between the planets are literally astronomical. It takes minutes to hours to even days for signals to propagate at the speed of light among the various planetary destinations or destinations to the asteroids or to moons of the various planets of the solar system. And so that system is beginning to deploy. We're starting to see prototypes on Mars and in orbiters and on the surface. These new protocols have been running on the International Space Station for over a decade. And the return to the moon missions, Artemis, for example, Gateway, and others from other spacefaring nations are starting to emerge, so that this last half of this decade will be very much focused on expanding to the moon. And then, of course, in the 2030s, the expectation is that we will be sending manned missions to Mars and possibly beyond. So there is much to look forward to in the internet, work to do on the terrestrial version to make it safer, more secure, more private, and of course to implement the expanding interplanetary internet in order to make use of the techniques as we work our way outward beyond planet Earth. So I hope that the conference will address at least some of the problems that we know we have to solve and perhaps make suggestions for progress that we can accelerate. I can't be there in person, but I hope that someone takes good notes and shares the outcomes so that all of us can benefit from the discussion that you have during this conference. Meanwhile, see you on the net.